So as we're reviewing for our quiz for sections 4.8 to 4.10, we are moving on to problems number 42, 43, and 44, which all come from sections 4.9. Now remember sections 4.9, we covered problems both where you're asked to graph two variable quadratic inequalities, where you have to keep in mind, oh, do I use a dotted or solid line? Where do I shade? As well as one variable quadratic inequalities where we usually solve algebraically and then often we confirmed graphically. And for word problems, we often just went straight to our graphical solutions, and that's totally fine. But do know that you could be asked to solve them either algebraically or graphically. So for 42, 43, and 44, they ask you to solve them all technically graphically, but again, let's focus on the algebraic philosophy behind it. So for problem number 42, I'm going to go ahead and challenge you to solve it algebraically. So that's a problem where it looks like I would be able to solve it by factoring. So I would multiply, and again, I'm just looking at my first values. I'm ignoring that less than or 0 until the very end. So I want to be able to factor this guy. So I've got x and x. This would use divide and slide. So I'd multiply that 2 and 5. I'd get 10. Two values that multiply to 10 and add to 11. Oh, that's 10 and 1. My signs are the same. They are both minus. Minus 10, minus 1. Divide and slide by 2. So then I'm left with x minus 5 and 2x minus 1. So setting those separate sets of parentheses equal to 0, I find that my solutions are positive 5 and positive 1/2. So as I place those on a number line, remember I want to go in order from least to greatest. So I have 1/2 on the left, positive 5 on the right. And from here, I would want to test those three intervals. So I've got the interval to the left of positive 1/2, between 1/2 and 5, and to the right of positive 5. So I pick a value in between each of those to test. So I would say, you know what, always test 0 if you can. That looks like it's going to be on the left, so the far left interval. And then test 1, might as well, because that's going to be between 1/2 and 5. And then let's test 6. I'm going to go ahead and plug them into my very original inequality, just because why not? So when I plug in 0, I'm left with positive 5 is less than 0. That is not true, so that means that I'm not going to shade to the left of 1/2. But when I plug in positive 1, I'm left with 2 minus 11, which is negative 9, plus 5, which is negative 4. That is, in fact, less than 0. So that one is a true statement. I'm plugging in 6. I have, 6 squared is 36 times 2 would be 72 minus 11 times 6. So 72 minus 66, we are up to positive 12 plus 5 would give us positive 17. Is 17 less than 0? Nope. So that means I don't want to shade in that final region to the right. Now I just have strictly less than, so that means I'm going to want open dots at 1/2 and 5, and I want to shade where it's true. So that was true from 1/2 up to 5. My last step is to write that final interval in terms of inequality notation. So that means that I want my solution x to be trapped between, 1/2 and 5. Now the reason I want just less than signs in between and not less than or equal to is because of the sign I was originally given. I was originally given less than, and so that means that I had open circles, which means that my final solution is just going to be 1/2 is less than x, which is less than 5. Now the same idea for number 43, but I hate having a negative leading coefficient, regardless of whether I'm going to factor or solve using the quadratic formula or whatever it may be. So my first job is to just get rid of that, just because why not? We certainly can. So when I do, I want to be able to divide everything by -1. But let's keep in mind, if I'm dividing by a -1, I have to go ahead and change that inequality symbol. So I'm going to have a positive x squared minus 4x minus 3 is less than or equal to 0. Because whenever I divide by negative, I have to remember to flip my inequality symbol. Now, although this one looks like I might be able to factor it, I actually won't. So I'm going to have to solve this guy using the quadratic formula. When I do, I'm going to go ahead and skip that step, because I'm going to assume you ladies are able to solve x squared minus 4x minus 3 equals 0 using our quadratic formula. And when we do, we find that our solutions are 2 plus or minus radical 7. So in terms of a number line, I'll have 2 minus radical 7 to the left of 2 plus radical 7. And then from here, we would need to test our intervals. So radical 7, in terms of an approximation, that's going to be between 2 and 3, right? Because that's between radical 4 and radical 9, right? Radical 4 is 2, radical 9 is 3. So just approximating, I know that I'm going to have 0 in that interval. And then for the sake of, I don't know what that actually is as a decimal, let's go ahead and pick values way to the left and way to the right of those values. So notice this time around I have less than or equal to, so that means I'm going to want closed dots at 2 minus radical 7 and 2 plus radical 7. And then I am only going to take the time to plug in 0. I will leave it up to you ladies to plug in negative 5 and positive 5 to see what happens. While plugging in 0, notice that we get, 0 squared is 0, minus 4 times 0 is 0, minus 3, it's just negative 3. Is less than or equal to 0? Yeah, that is true. So that means that we do want to shade between 2 minus radical 7 and 2 plus radical 7. Again, you still want to plug in negative 5 and positive 5. You're going to find that they're not going to work though, but take the time to do that. So as we write our final answer in terms of an inequality, we'll find that we only want the x's that are between 2 minus radical 7 and 2 plus radical 7. Again, less than or equal to because of the inequality symbol they originally gave me. Lastly, number 44. So again, I will leave it up to you ladies to set that equation on the left-hand side equal to 0 to find your solutions for x. When you do, you'll find that your solutions are x equals negative 3 plus or minus radical 21. Again, we'll throw those on a number line. So negative 3 minus radical 21 is obviously going to be to the left of negative 3 plus radical 21. So again, we would test values in between here. Radical 21 is going to be between 4 and 5. So negative 3 plus radical 21 is actually going to be beyond positive 0. So it's going to be a little bit to the right. So we would pick 3 numbers, one in the interval all the way to the left, one in the interval in between, and one in the interval all the way to the right. We would test those values, and we would see which ones actually work out, which ones are true. We'd plug it back into our original inequality, and we would see what would happen. Now, when you pick a value in between those, so in the middle interval, you're going to find that it doesn't work. But when you pick values to the left of the negative 3 minus radical 21 and to the right of negative 3 plus radical 21, you're going to find that they both work. So those are both true, and we have strictly greater than, so that means I have open dots, and then I want to shade where it's true, so that means I want to shade the outsides of my inequality. Writing my answer in terms of an inequality means, I want x to be less than negative 3 minus radical 21, or I want x to be greater than negative 3 plus radical 21, and that comes back to how we write inequalities based on a number line graph. So in terms of a decimal approximation, that would say x is less than negative 7.6, or x is greater than 1.6.